A rectangular sheet of metal made of uniform material is 9 cm long, 8 cm wide. 6 circular holes of radius x are drilled through the sheet. I. Find an expression for the volume of the metal sheet before and after the holes were drilled if h is the thickness of the metal. II. If the ratio of the new volume of the sheet to the original volume of the sheet is 13:20, find, correct 2 decimal places, the value of x. So you have been given this metal sheet in the shape of a cuboid or a box, and the dimensions are 8 centimeters by 9 centimeters by h centimeters. The question says that 6 holes, that is 6 circular holes, are drilled through this metal sheet, and each of these holes is having a radius of x. The first part of the question says we should find the volume, an expression for the volume of the sheet before and after the holes were drilled. And if the ratio of the original volume to if the ratio of the new volume to the original volume is 13:20, we should find the value of x. If you look at this sheet very carefully, you can see that before the holes were drilled, the volume of this metal sheet is equal to the volume of the cuboid, because before the holes were drilled, there will not be any holes here, so the volume of this metal sheet will be the same as the volume of the cuboid. Volume of this cuboid is equal to 8 centimeters times 9 centimeters times h centimeters, since the volume of a cuboid is length times breadth times height. So the volume of this cuboid is 8 centimeters by 9 centimeters by h centimeters, and that will give us 72 h centimeters cube, meaning that the volume of this cuboid before the holes were drilled is 72 h centimeters cube. The questions also said we should find the volume of this cuboid, or the volume of this metal sheet, after the holes were drilled. So the volume of the metal sheet after the holes were drilled. Volume of the metal sheet after the holes were drilled is equal to volume of the cuboid minus volume of the 6 holes. So now we have drilled 6 holes into the metal sheet as we have here. So the volume after the holes were drilled will be the volume of the cuboid, that is before the holes were drilled, minus the volume of the 6 holes. Okay, so now we need to find the volume of the 6 holes. If you drill a circular hole into a metal sheet like this, or if you drill a circular hole into a sheet like this, the holes will be in the shape of a cylinder. If you drill a circular hole into a sheet like this, the holes will be in the shape of a cylinder. So it means that the shape of these circular holes are cylinders. So this is in the shape of a cylinder, this is in the shape of a cylinder, and all the holes are also in the shape of cylinders. So the volume of these holes will be volume of cylinders. And since they all have radius of x, it means that they are all going to have the same volume. Now look at something. If you draw a hole through this metal sheet, the height of the cylinder that will be created will be the same as the height of the box, of the rectangular box or the cuboid, since you draw the hole from the top part here to the bottom. So the height of the cylinder will be the same as the height of the cuboid or the rectangular box. So 1, the holes will be in the shape of cylinders, and 2, the height of the holes will be the height of the cylindrical holes will be the same as the height of the box or the cuboid. Okay, so we can say that the volume of the 6 holes is equal to 6 times volume of the cylinder created by one hole. Since they all have a radius of x and they all have a height of h, they are going to have the same volume. So the volume of the 6 holes is equal to 6 times volume of the cylinder created by just one hole. And this will give us 6 times volume of a cylinder is equal to pi r squared h, where r is the radius of the cylinder and h is the height of the cylinder. So in this case, the radius is x, since the radius of the holes are x and the height is h, since the height of the holes will be the same as the height of the rectangular box. So this is equal to 6 times pi times the radius is x and the height is h. We are going to have 6 times pi will give us 18.85. So we have 18.85 s squared h centimeters cube. So the radius was x. So you have 6 times pi times s squared times h. 6 times pi will give us 18.85. So you have 18.85 s squared h centimeters cube. Now this is the volume of the 6 holes. Remember we said that volume of the metal sheet after the holes were drilled is equal to volume of the cuboid, which is 72h centimeters cube, minus volume of the 6 holes, which we have now found to be 18.85 s squared h centimeters cube. So volume of the metal sheet after the holes were drilled is equal to 72h centimeters cube minus 18.85 s squared h centimeters cube. We have h here, so we can factorize that out, and that will give us 72 minus 18.85 s squared into bracket h centimeters cube. So this is the volume of the metal sheet after the holes were drilled. The question gave us a ratio and it told us to use that ratio to find the value of x. Okay, so the question says that the ratio of the new volume of the sheet to the original volume of the sheet is 13:20. From ratios, we learned that if we have a ratio 13:20 is the same as 13 divided by 20. So what this means is that the new volume of the sheet divided by the original volume of the sheet is equal to 13 divided by 20. But what is the new volume of the sheet? The new volume of the sheet is the volume of the metal sheet after the holes were drilled. And we got 72 minus 18.85 s squared into bracket h centimeters cube. So this is the new volume of the sheet. That is the volume of the sheet after the holes were drilled. The original volume of the sheet is the volume of the metal sheets before the holes were drilled. That is the original volume. We find out that that is 72h centimeters cube. So this is the new volume and this is the original volume. Now the question says that the new volume divided by the original volume is equal to 13 divided by 20. That means that 72 minus 18.85 s squared h centimeters cube divided by 72h centimeters cube is equal to 13 divided by 20. So let's cancel some common terms out. So centimeters cube and centimeters cube will be gone. H and H will be gone. Okay, so after doing that, we are going to have 72 minus 18.85 s squared divided by 72 is equal to 13 divided by 20. So here, in order to find the value of x, we are going to cross multiply. That is, the denominator here, which is 72, will multiply the numerator here, which is 13. And the denominator here, which is 20, will multiply the numerator here, which is 72 minus 18.85 s squared. So we will do cross multiplication here. This will give us 20 into bracket 72 minus 18.85 s squared is equal to 72 times 72 times 13. So we have 20 into brackets 72 minus 18.85 s squared is equal to 72 times 13. We open the brackets here. We will have 1440 minus 377 s squared is equal to 936. We group like terms. We have 1440 minus 936 is equal to 377 s squared. and this will give us 377s squared is equal to 504, since 1440 minus 936 will give us 504. So we divide the left hand side by 377, we divide the right hand side by 377, and this will give us s squared is equal to 1.34. We take square roots of both sides, and x will give us 1.16 centimeters. So that means that the radius of the holes drilled through the sheet is 1.16 centimeters.